As everybody knows, the telephone has changed a good deal over the years. But it has also become responsible for a lot of useful cousins whose kinship isn't always realized. To name just a few, there's the teletype, which speeds the written word across the miles, remote feeding of electronic brain calculators, nationwide television transmission, the remote control of systems for industry, and more familiar, the increasing use of those added telephones which are saving so many steps today. These and a host of others made by the millions or one of a kind are the tools of telephony. And the reason they are always at hand and ready to serve is that some very able men and women made them, or installed them, or warehoused them near the point of use, or purchased them. To the Bell system, the American Telephone and Telegraph Company, and the operating companies across the nation, this someone is the Western Electric Company, with manufacturing locations in more than a dozen states, 17 installation areas from coast to coast, a far-flung purchasing system, and a chain of distributing houses that covers the nation. These four activities are interdependent. Each must link into the others to keep down the cost of service. Nearly everything a Bell Telephone Company needs comes through orders placed on a Western Electric distributing house nearby. There are over 30 of these houses, and no telephone need is more than a few hours away from these handy department stores of the Bell system. 1,000 and more requisitions a day come from a telephone company into a typical distributing house. 9 out of 10 of them for shipment the same day. The smaller items are stored along half-mile conveyor lines into which the dispatcher feeds his orders. A typical house may stock 10,000 different items, including 3,000 types of apparatus and 1,800 different kinds of printed matter. Although the stock turnover is rapid on most items, Western must still keep ready to supply replacement parts for equipment installed many years ago. The loaded hampers go to the telephone company's loading platform for transport during the night to telephone work centers. Some of this material will be installed tomorrow morning while it's still being built. The trucks come back to the houses with used equipment that has been removed from service. Some of it just needs reconditioning. But some isn't worth repair and goes into various channels of salvage. Old cable and wire, metal parts and the like are shipped to the company's salvage plant on Staten Island, New York, where the Nassau Smelting and Refining Company reclaims the copper, lead, and other metals. This operation has been particularly useful to the system in the recurring periods when copper has been scarce. The distributing houses recondition all sorts of equipment, but the volume job is on the telephone instruments themselves, which turn over faster than you might think. The disassembled instruments are classified by the amount of work which needs to be done. and feed along the conveyor network into the appropriate shop section. An ingenious system of pins in the traveling boxes automatically selects the right route. All telephones get replacement parts as needed and a thorough checkout on the test panel. When nature goes on the rampage, the men of the distributing houses get on the job, regardless of hours or weather. Somewhere out there in the storm, other telephone men are fighting to restore service to stricken communities. They must have tools and supplies, what they need, all they need, when they need them. The distributing house is ready. Aerial wire, drop wire, pull hardware, and 100 other necessities will be on the emergency scene in a matter of hours, to be backed up by reserve stocks rushed from the factories. It's on the way. No matter how severe the storm or how great the damage, not one man on the reconstruction team has his work delayed by lack of material. Things the Bell operating companies need, but which Western Electric does not manufacture, come from suppliers in more than 3,000 American cities and towns. The purchasing people buy them, along with all the supplies, machinery, and raw materials which Western needs for its own operations. The nationwide orders add into such a volume that these buyers can be specialists. Some men, for example, buy nothing but wood and wood products, from plywood to poles. They know as much about their specialty as a man can know. Many suppliers sell Western a big part of their output, which lets them save on sales and credit expense. The Bell companies share these savings, but the supplier must make a fair profit, so he'll continue to be a healthy, dependable source. Take these high-speed presses for printing millions of telephone directories. Often, the pooling of these orders justifies installing expensive machinery, and again, Bell companies share the savings. Suppliers come in all shapes and sizes. Some are the giants of American industry, skilled in the manufacture of unusual items, such as these microwave antennas. And often the volume justifies keeping Western's own inspector right in the manufacturer's plant. But many of the more than 30,000 suppliers are as small as this little enterprise, which turns out very satisfactory wooden pins for cross arms. And wherever possible, purchases are made from local merchants or dealers. The $1.25 billion dispersed annually for materials and outside services makes itself felt in many places. Probably your town was one of the more than 3,000 communities to which these checks were mailed. The purchasing people also buy the raw materials which the company uses in its factories. Copper, almost 1/10 of all copper consumed in the nation. Steel for manufacture into thousands of precision parts. Plastics for insulating wire, covering cable, and making the familiar telephone sets. And others by the hundreds in quantities large and small. But before materials can be processed, the products they will become must be developed and designed. This is the job of the Bell Telephone Laboratories, owned jointly by Western Electric and AT&T. Much of their research is fundamental, investigating the frontiers of present knowledge. From one such project came the device which will affect our whole material way of life, the transistor. New tools of telephony start in the laboratories informally, like this, but they must sometime end up like this. And this is the challenge to Western's manufacturing division. Of course, the factories make not only the telephone instruments, but in the various manufacturing locations spread over more than a dozen states, they make thousands of other tools of telephony that most telephone users will never see. Some of the plants are modest in size. Some have to be very large indeed. If the production men are to hold prices down in the face of rising wages and material cost, manufacturing must be constantly more efficient. Here is such an effort, teamwork in action. The wire spring relay for switching telephone calls in central offices came to Western from the laboratories as an experimental model. Their men worked in liaison with Western engineers to ready the device for quantity manufacture. Production would ordinarily have been set up in standard assembly groups like this. But the stakes were high. These relays were needed by the million, and Western's development engineers set about designing an automated machine that would perform a whole series of complex operations in sequence to turn out the wire spring combs for the relay faster, cheaper, and better than manual methods could ever achieve. The investment is substantial, but the economy of automated production makes it pay. The 150,000 and more items in these product files are of infinite variety. From huge, like these reels of cable, to small, coils for telephone ringers wound by the million and barista buttons for assuring quietness in telephones, to outright tiny, so very tiny that they must be processed under a microscope. The Allentown plant is in the vanguard of today's growing trend toward miniaturization, whereby an entire telephone central office may someday fit into a space no larger than a living room. It calls for precise factory techniques, as in shaping the filament for a small electron tube. Micro-manufacturing, you might call it. Here, a tiny grid is wound with wire the operator can hardly see. Thermistor beads act as tiny switches, conducting electricity in larger volume when hot than when cold. Skills like these, once rare and costly, have now been made practical for volume application. Wire is always the target of nature's attacks. Wire in flooded conduits. Wire loaded with ice. Wire beaten by desert sun and heat. Even on pleasant days, the relentless attack continues. Vulnerable to all these hazards, for example, is the wire from the pole to the subscriber's house. And a new kind of wire from the Baltimore plant is reducing this cause of service interruption. It begins with a steel core for strength. A series of plating operation coats the steel with copper for conductivity and other metals to resist corrosion. The process developed by Western's engineers is called electroforming. It is continuous and nearly automatic. The entire building is operated by only 6 men. The strong wires, now coated with copper, are laid in a bed of rubber and covered with tough neoprene to resist abrasion. A hurricane tonight would leave this floor nearly bare tomorrow. Another new type of telephone wire, coated with colored plastic at 2,000 feet per minute, will provide the long years of trouble-free service the telephone system has to demand. Reducing red-hot billets of copper to wire brings out some unusual teamwork between the men and their machines. Each time the hot copper passes between rollers, it becomes thinner. When down to a 1/4 inch, it is ready to be cleaned and drawn into wire. Here, the wires enter a huge machine which insulates them with a coat of paper. The insulated wires then come together in a bundle. These cable units are combined on a custom basis, more or fewer of them according to the needs of the telephone company. The whole cable may contain over 4,000 individual wires enclosed in one sheath. Today, protective plastic replaces the traditional lead sheath on many cables. In the future, the sheath may be of aluminum, formed directly on the cable. To the manufacturing engineer, no process is ever final. Intricate wiring for telephone switching equipment, slow to make by hand, now flows from a machine which starts with wire on spools. A small network, a complicated assembly of miniature components needed in every telephone, now gets its program of tests on an automatic machine. This little glass-enclosed switch, compact and positive, when made by hand, cost too much for widespread use. So the engineers developed a machine which is a miniature factory in itself. Starting with metal parts and glass tubing, going through a self-controlled sequence of operations, checking itself for quality, and delivering the switches in great quantity at a fraction of their old price. The little signal lamps, which flash on telephone switchboards, light up the sometimes overlooked fact that automation must be applied with common sense. Despite the huge volume of these tiny lamps, 10 million of them are made each year, the clever machines still need the supervision of human hands, deft hands controlled by human intelligence and judgment. A gleaming crystal of germanium spins up from a batch of molten metal ready to be sliced into the tiny wafer which is the heart of the transistor. The growing family of transistors is dropping in cost as mass production engineering continues. Compact and cool, transistors use so little current that today's familiar telephone bell, which rings on 85 volts, may someday be replaced by a transistorized musical tone which needs only 1 volt. The Indianapolis plant is a good example of modern volume manufacture. Here are made the telephone instruments themselves, 7 million of them in a single year. A few ounces of plastic become a handset housing in seconds by the use of a polished steel die that took 6 months to make and cost $55,000 a set. Again, expensive tools that cut production costs are made feasible by pooling the orders of all the Bell companies. Color rides the conveyor lines today. Colors to go with any decor and convenience to match the color. Wall telephones, bedroom telephones, speaker phones, volume control phones, illuminated dials and answering sets, and each must be engineered both for convenience and use and for production at a feasible price. An ideal fusion of machines and people. And despite the machines, still a lot of people. In a typical year, Western pays nearly $750 million to its many thousands of men and women, a third of whom have been with the company for 10 years or more. From the vast Kearney plant and from the even bigger Hawthorne works comes the equipment for automatically switching telephone calls in central offices. Engineers custom design each addition or expansion from files which detail every central office in the Bell system. Since no two towns are alike, every central office must be different. So the combination of frames, amplifiers, and so on is tailored to the particular community requirement. But this custom combination is then built out of standard volume-produced units, which differ in number rather than design. The wire wrapping gun, which makes connections without solder, is saving time as well as solder on assemblies like this. These huge frames for a new central office are just one part of the world's biggest electronic brain, the Bell System plant, where a person can put a problem into the computer in Seattle and seconds later get his answer from Miami. A typical operating company order for central office equipment calls on Western to engineer, furnish, and install. From factory merchandise docks, the equipment goes out to Western's installers. The installers, working out of headquarters in 16 far-flung cities, are the Marines of the system, the mobile force that rolls into a town, moves into an empty space in a telephone building, and proceeds to fill it with pulsing, clicking equipment. This job has been in active preparation for many months, and the supervisors have enough blueprints and specifications to paper the walls of their big room 10 times over. The job begins. New men learn from the old hands, mastering one skill and moving on to a more difficult one, until they become old hands themselves. The hundreds of wires in each of these cables are to the layman as alike as blades of grass. But each one of the thousands of strands has its own origin and seeks its own destination. In a single year, Western's installers may connect 2 million dial lines. The custom-made apparatus flows from the factories to the job, each frame and panel skidded to its predetermined place on a schedule set up before most of it was manufactured. Quite a crew, these installers, scattered in small coast to coast, but effectively as close together. Quite a crew, these installers, scattered in small groups from coast to coast, but effectively as close together as though all of them were in the same room, working with the same tools on units manufactured to the same specifications, making connections to tie in with other circuits being connected at the same moment by distant men whom they may never meet, so that a call placed at any one of the millions of telephones in the system can get an answer from any other telephone, and to do it so dependably that the caller will keep right on taking his tools of telephony for granted. Now the job is nearing completion, and the Western supervisor and the telephone company wire chief bring their people together into the team that will test and check and observe until this infinitely complex web of circuits is proven ready for service. Every connection, every switch, every relay in the thousands of circuits will either check out OK or drop a card automatically punched to spot what is wrong. OK, and the time grows shorter. Coordinating committees from Western and the telephone company match their schedules and point for the big date, the hour of the cutover. And now the new office meets its major challenge, the load test, which dumps a flood of simulated calls in much greater volume than should ever come through the cables. If it passes this, it passes. Finished like 99% of the projects on the scheduled date. And the force, now ready to move on, says goodbye to its local friends. The supervisor stuffs the last of his papers into his familiar brown briefcase and moves on to the next job. Today, a substantial part of Western's manpower and machines is devoted to the national defense. From one plant comes the fantastically complicated Nike guided missile system, which will locate a skyborne invader, track him, and guide the warhead to the kill. To train men of the Navy, Army, and Air Force in using the new electronic weapons which Western produces, members of the Field Engineering Force follow the flag wherever it goes. And it goes to some far places. To span the Arctic wastes with the 3,000-mile line of radar stations known as the Dew Line, the government called on the company's unique experience in organizing new and complicated undertakings. 200,000 tons of equipment and supplies had to be moved into a forbidding region and then installed. Here, where once a man considered himself lucky just to stay alive, he dropped huge bulldozers from the skies as a matter of below-zero routine to complete this new frontier of defense on schedule in just 32 months. At home, the facilities of the company expand with the needs of the nation. New factories, new distributing houses, more employees. But the spirit is still Western Electric. A nationwide structure built on more than 3/4 of a century of service to the Bell companies and to telephone users. Service in purchasing the most suitable materials at the fairest price. Distributing the materials to the right place at the right time. Manufacturing tools of telephony to serve dependably for decades, and service in installing the tools to meet the ever-increasing needs of a whole nation of customers. Service, in the final analysis, by people. Thousands of loyal and industrious men and women, without whom even the finest plant would be only brick, concrete, and dead metal. Over the years, a miracle has come to pass. Until today, any person can talk directly, voice to ear, with any other person in our whole country and in much of the world abroad, clearly, quickly, and at low cost. Through the most active period of America's growth, it has been the privilege of the Western Electric Company to engineer, furnish, and install the tools of telephony, to the end that the progress of the past may serve as the promise of the future.